Good evening, everyone. Hello, and welcome to Mapbox Unboxed, the Location Technology Edition. We're broadcasting live from Helsinki, and my name is Anna Steli. I'm part of the management team here in Europe at Mapbox, and very excited to guide you through this evening tonight, which is going to be all about metrics, how we built them and how we further develop them, and like shedding some lights on stories and what worked and didn't work from two different angles with two different people here. We have Johann Muszynski from the Wolt team. He's an engineering manager at Wolt, focusing on logistics and optimization. And we have Daniel Ecke, who is part of the Mapbox engineering team. And yeah, welcome the two of you. How are you tonight?
Thanks for the introduction. Super nice to be here. The office is great. And to be honest, it's kind of amazing to be speaking in front of people now for the first time in around 2.5 years. It really hits different.
I bet.
Yeah, same. It's really nice to see you both in person, even though we've been talking a while now during the rehearsal and other parts, but now it's cool to see you in person.
Awesome. Great. Before we get started, I do want to say to our online viewers, please drop comments in the comments box. Any questions that you have, we're going to divide this conversation into two parts. First, Johann is going to dig into Wolt metrics with us, and then Daniel is going to give a presentation, and we want to make sure that you get all your questions answered. So feel free to collect them during the conversation. Cool. Let's dive in. Johann.
Yes.
So maybe to level set with everyone, I think most people here know Wolt, but in case they don't, can you tell us what your company does?
Sure. So Wolt is a Helsinki-based tech company. It's building a commerce platform with the intention of connecting people who want to order stuff online with people selling things and people doing deliveries. The overarching vision is to bring the shopping mall into your pocket. We joined forces with DoorDash recently. We've been working together officially since June, and we now work on a number of different technologies, much more than just the logistics platform itself, in order to fulfill this vision of bringing the shopping mall into your pocket. So for instance, we now have our own quick commerce chain called Wolt Market. It's like any other grocery store in the app, but it's a grocery chain that we actually operate ourselves completely in-house. And I'm going to put my engineering hat now on and say that sort of Wolt Market, at least for me, is a bit of a source of engineering envy. I joined Wolt in 2018 when the engineering team was fairly small, and joining, for instance, Wolt Market today is a bit like joining Wolt in the early days. They have a small dedicated engineering team, and they're focusing on really juicy greenfield engineering problems. So I kind of sometimes daydream about switching over there and working on problems such as minimizing the distance that you have to travel inside a grocery store in order to fulfill a customer's order. I'm from logistics, so of course that's my preference of problem to solve. So there's that. There's a number of things going on in Wolt. That's sort of Wolt in a nutshell at the moment.
So you've been describing how you love working at startups, and you have joined Wolt in 2018. So you've had quite the journey with the company. How many countries does Wolt exist in now? How many cities do you service?
Wolt operates in 23 countries at the moment, and roughly 300 cities. We have very recently crossed the 300 city threshold. We have countries like Finland and Japan, where we have a large number of cities, but the cities themselves aren't necessarily that large. And then we have countries like Israel and Denmark, where there aren't a lot of cities, but the cities themselves are very, very large in terms of order volume. So cities like Copenhagen and Tel Aviv are on any given evening, usually they have by far the most ongoing orders. So for my team, the logistics optimization team, that's a pretty interesting challenge.
Yeah, maybe you can talk a little bit more about that. What does your team do? What are they responsible for?
Right. The logistics optimization team is responsible for two things at the moment. We are building machine learning models, and we are building the logistics optimizer. We build machine learning models to estimate the delivery time. So, when you're browsing the Wolt app, you're looking for restaurants on the discovery page, and you see, each restaurant has a small delivery time annotated on it. So delivery in 20 to 30 minutes, for instance. That's the output of one of our machine learning models. We are also using machine learning to estimate every step of the delivery itself. So things like estimating the travel time between any 2 points in a city, or estimating the preparation time that it would take a merchant to prepare an order, for instance. We feed some of these estimates into the logistics optimizer. And the logistics optimizer uses these estimates to make routing decisions, and it produces routes in almost real time. By routes, in this case, I actually mean sort of sequences of tasks. Tasks being, the pickup or the drop-off task of an order. And we use these sort of task plans actually for two things. We use it as the basis of the task offers that we show the courier partners in the partner app, and we also use these task plans to generate the final customer-facing delivery estimate. So, in a nutshell, it's machine learning models for delivery time estimates and logistics optimization. That's what we're about.
It seems like a very central problem to sort of any delivery platform, right? Many of our customers deal with a similar challenge. What would you say is unique about building a delivery platform? What differentiates your task from other parts of Wolt?
I would say what is unique about logistics optimization, I'll take a step back here actually. The Wolt backend system overall, it's responsible for connecting the merchant app, the customer app, and the courier partner app all together somehow. And what's unique about working in logistics is the fact that we're supposed to connect a customer's delivery with a courier partner. And in order to do so, we need to actually communicate with all three of these apps at once. So this makes our system fairly complex with all sorts of nasty gotchas and feedback loops. I could say it's complex, but I could maybe demonstrate it a bit by breaking down a delivery into some steps to maybe illustrate what I mean here. So after you've placed an order in the app, the main Wolt platform throws the ball over to the delivery platform, and it now has to figure out how to make this delivery happen. The first thing it has to do is it has to generate a time estimate of when a courier partner could be at the merchant. We need this time estimate because we need to negotiate a potential pickup target time with the merchant. So the merchant sees this time estimate on the app, and then they can take it, or they can actually add more time if they're very busy at that moment. Once the merchant has selected the time in the app, the delivery is confirmed, and we can actually start showing the task offer related to this delivery to couriers who are online in the city at that time. And we can't show the task offer to just any courier because we might have a really large or really heavy order, which would then actually have to be fulfilled by a courier partner with a car or maybe even a van. So we have these sorts of constraints that we need to adhere to. And then finally, the courier partner can actually choose to reject the task in the app, in which case we need to try to find another potential courier partner as fast as possible. And this is the reason why the logistics optimizer is actually sort of a real-time system, because it has to has to respond to many dynamic events of couriers rejecting tasks, merchants overriding the time we planned. Otherwise, we just lose time, and our the overall delivery time of your order would just slow down. So that's sort of the gist of it.
Yeah, I think that's very interesting that you point out all these real-time adjustments with the merchants and the courier partners. But let's dive into what I'm interested in is like all these different sections that you have to satisfy in the Wolt business. So you mentioned those different apps. There's the consumer app that we see, then there's the career partner app, there's the merchant app, and overall there's the Wolt business that is trying to stay profitable. So what are the metrics that you have to, or that Wolt set out as a business for you to follow to satisfy all these different needs?
Yep, that's a good question. Like you mentioned, we have these different groups of users, and we need to keep it profitable. In order to do so, we definitely need to measure a bunch of things to find the right balance, because being profitable might be at odds maybe with the absolutely ideal customer delivery experience. So we definitely need to find the right balance there. How do we go about measuring it? I would say that we need to start off with a few high-level metrics. I think I heard someone mention that Mapbox follows at least some metrics regularly in like regular company-wide calls or something. We also do that, so we have like a big company-wide call where we go over how our countries are doing, and we measure a bunch of different things there. The business is interested in a number of high-level metrics. I would say at the moment our team is interested in service quality metrics. By service quality metrics, I mean things like user ratings. How did users rate the app, or how did they rate individual deliveries? After a Wolt delivery, the app prompts you to rate the food and the delivery, so we can collect data on that. So that's a consumer. That's a very consumer-related metric. Another consumer-related metric, but also a business metric, is average delivery time. The delivery time being just the time it took from placing your order to the time it was actually arriving at your door. We're also very interested at the moment in delivery punctuality, which is simply the number of orders which were delivered later than the initial time that we quoted in the app, but also how late these orders were on average. So these are some service quality related metrics that we're looking at, but I would also like to say that they aren't really, I think for us as a team, they aren't really enough. These are high level metrics which tell us a little bit about how well we're doing, but they don't necessarily tell us what customers want from their delivery experience. They're also not necessarily enough for us to evaluate whether the changes we made to the logistics platform were actually any good. So I think we need to dig a bit deeper beyond these high-level metrics.
Yeah, so we're thinking about metrics actually a lot at Mapbox. It's also part of the reason why we're having this conversation about metrics today. And I think one of the outcomes of those weekly calls was, are we actually measuring the right things? Are we measuring the things that really matter to the end consumer? And so one of the follow-ups that we could observe internally at Mapbox is that there was quite some thinking within the engineering teams about how to continuously develop their own underlying metrics to feed up to this overall business metrics. What is the process for your team at Wolt? How do you do that, iterating on those metrics?
Yeah, that's a good question. I think, as amateur as it sounds like, I think our iteration process is sort of based on iterating based on trial and error at the moment. I think, like I mentioned earlier in one of my answers, our system is quite complex, and we don't necessarily understand how all the parts work together. And it's sort of, we have built some kind of a system and it works in a certain way in our cities. And up front, we can't necessarily know the effects that changes might have in those cities. So for instance, maybe I'll illustrate a little bit what I mean about this complexity. Back in the really early days, we were looking mainly at some of the higher level metrics, like for instance, average delivery time. And if, say, we had to evaluate a change to the logistics optimizer, we decided to maybe roll it out in Finland, and say it snowed a lot on that day in Finland. Then when we were looking at the average delivery time, we would have just seen that, oh hey, the delivery time went up a lot, even though the logistics optimizer change was supposed to improve delivery time and bring it down. It's very likely that the optimizer change actually had an effect, just that we weren't really accounting for the weather. And there's actually a lot of other stuff in things like average delivery time which we need to account for. There's so much randomness in that metric that we need to actually look at a number of other metrics to explain away the random variation that we see in things like delivery time or delivery punctuality. So that's the process, and we're mainly sort of finding out things that we are able to measure, testing to see if maybe it correlates with some of the randomness we see, and then we sort of choose what seems to work.
Yeah, so you just brought up network effects, and weather is one of them, but there are many, many others, like incidents. And you've worked with our products. Maybe can you dive into how you work with Mapbox and how, unpack the story a little bit about how that brought you to develop your metrics further?
Yeah, sure. So Wolt uses actually a number of different Mapbox products at the moment, but the logistics team specifically uses the Matrix API. So for those of you who don't necessarily know, the Matrix API is something you can use to fetch travel time estimates between a number of points. So for instance, in the optimization team, we're interested in things like what's the travel time between all of these courier partners and all of these tasks. So that's something we use the Matrix API for. We're currently using the Matrix API in 2 different places. We're using it inside the logistics optimizer, and we're using it to also generate the final customer-facing delivery time estimates. We're interested in one very specific feature of Mapbox's Matrix API, which is the ability to generate live traffic-based travel time estimates for cars. Because we had this hypothesis a long time ago that accounting for the street-level traffic might help the logistics optimizer somehow make better decisions on the task plans that it generates. And then, of course, it could also help improve the delivery time punctuality of the customer-facing estimates we generate. So those were the 2 hypotheses that we set out to validate when we integrated the API.
I think that's a very reasonable hypothesis. We all know the story where order something and then there's a huge traffic jam or some car accident and the delivery is not on time. So Johann, why was it not super straightforward to prove the hypothesis?
Yep. I have to comment on that. Delivery time thing. We have this thing called Wolt minutes sometimes, where because something unexpected happened, the delivery time starts to slow down in the app, and that's exactly the thing we want to help improve. But what happened when we integrated Mapbox Matrix API? We wanted to move fast, so we decided to just turn it on in 2 cities and see whether we could see the results we were expecting. We picked 1 city in Finland and 1 city in Japan. And then we waited a while and we got some data, and the results were they were conflicting. We saw definite delivery punctuality improvements in one of the cities, but in the other city, which was supposed to be really similar, we didn't see at all the same improvement. So we scratched our heads for a while and came to the conclusion that we had done exactly the thing that I said we shouldn't do a couple answers back, which is to say that we had enabled the Matrix API in 2 cities, and then we had looked at high-level metrics, average delivery time and delivery punctuality, without accounting for all of the random fluctuations that we get on a daily basis.
The network effect you've been talking about before.
Yeah, just the sort of, confounding variables, stuff we don't control when we turn the Matrix API on. So we weren't accounting for changes in weather or city closures, things like that. So it was likely that there was some kind of effect, and we could probably see it if we approached it a bit more systematically. So if we would actually do a real experiment, then we could maybe see what the real effect was.
And what did you decide to do then to figure that out?
Yeah, so that's the thing which took a long time, as I'm sure the Mapbox team knows. So we decided to run a switchback experiment. It's an experiment which basically allows us to randomly turn Mapbox on and off. You can think about it like this. So basically every hour we flip a coin, and then based on the result, we see if we should turn Mapbox on or off. And we do this everywhere in all our cities independently. And we've actually been doing this now for the past 1.5 months. So even now, Mapbox is randomly being turned on and off, also here in Helsinki. And what we get by doing this is we get a number of deliveries which have been made with Mapbox enabled, when the order was placed, all the way until when it was delivered. And of course, we get a number of deliveries where Mapbox was turned off. And we get these deliveries when it was raining, or when it was sunny, or when it was the weekend, or it was a weekday, and so forth. So in a way, when we randomly choose bad or good weather, or weekdays, or weekends, or rush hour, actually the effects of these things, it just averages out. And what we're left with then is 2 sets of deliveries, which we can now actually compare. And when we've done this now, the last week, we've calculated the average delivery time over the average delivery time and the delivery punctuality over these 2 sets of deliveries. And finally, we can actually see a result which sort of makes sense, which is that in cities where we have a lot of courier partners with cars, the delivery punctuality got a lot better. And even the actual delivery time went down, which for us was kind of an amazing result. We weren't really sure we would be able to see that.
Hypothesis proven.
Yes.
That's great to hear. I'm sure I can speak for the Mapbox technical account management, product and engineering teams. That is very interesting to work with you on that journey. And I think we learned just as much in this period of time than you did. Speaking of learnings, what would you like to share as a piece of advice for all other developers developing metrics? Any tools or processes that you would advise?
I would say just keep on learning and dig deeper. We have this, now since we have joined with DoorDash, we have this rather cheesy tenet, which I actually like quite a lot. It's be a truth seeker. I'm going to put my manager hat now back on. So as engineers, you probably have a lot more insight than your managers might have on the systems that you're building. And most likely, if you see some high-level metric that the company is measuring and it looks like it's a bit counterintuitive, or you think that the metric doesn't reflect the actual effects of the system that you're developing, then dig deeper and be a truth seeker, because you'll likely have much more insight into the system that you're developing than your managers will. So that's it.
Cool. Great advice. Thank you so much. I know I've been asking a lot of questions, and we're at time. We're actually over time. So I would love to turn it over to the audience and see if anyone has questions here. Questions in the comments box.
I do have a question.
Yeah,
so
please.
Previously, when we had a bit of a discussion before the event to prepare about the topics that we are going to talk about, I think you mentioned Budapest as one of the examples of a interesting city because it's split by half with the Danube, and that complicates sometimes the delivery times. But not necessarily about Budapest, but can you maybe share which one is the most exciting or most difficult city from delivery point of view? Or is there some unique characteristics of some cities that might be interesting from that point of view?
Yeah, Budapest is one of the really interesting ones. It's the city which sort of prompted the whole, hey, should we need to account for live traffic in the first place? Because the country team there was concerned about the unique traffic conditions that they have. There's only a few bridges over the river, and it's a horrible source of, there are bottlenecks. But the courier partners have to travel regularly over the bridges, so that's certainly a challenge. I think the team has tried to work on this problem by sort of dividing the city up into regions to try to control a little bit the visibility of venues on different sides of the city, to try to restrict the number of times courier partners would have to sort of go over the bridges. And why we'd want to do this, it just, we kind of work around the problem, and it makes delivery times then also a bit more predictable, so we aren't so late all the time. So that's one challenging city. Another city which is challenging is actually Tokyo at the moment. It's really, really large. The distances can be really large there, so when you're looking at a map, it looks like, just a few blocks. How long could it take? And then you realize it actually might take the courier partner, 30 minutes to cycle from their current location to a task. So that's definitely a challenge as well. It's sort of affecting our thinking and what we need to do in the logistics optimizer to work around these problems.
Yeah, thanks a lot for the answer. Actually, Tokyo is also a bit of a challenge for us because it's a very condensed city, and there's a lot of features, plus all the symbols on the map is made with glyphs for their script. So it makes it a lot difficult to render. So I think it's a bit funny that it's both a difficult city from guidance and also rendering point of view.
Yep.
Are there any more questions? I actually have a spontaneous follow-up questions. So you mentioned different modes of transportation that your courier partners are using. Are there any cities that are like prone more to car delivery or more to bike delivery? And what would you say are the unique challenges for each of those delivery vehicle types?
Our courier partners can choose the mode of transport they use, but of course, depending on where you are in the world, it's sort of the vehicle types that our courier partners use tends to just be what people use in those cities. So for instance, in the Nordics, of course, cars are fairly common, and when it's winter, everyone is using a car. Barely anyone is cycling out there. I have to raise my hat, though, to those courier partners who do cycle in the winter even, or use those, what are they, those funny electrical unicycles. But then elsewhere in the world, for instance in Israel, a lot of cars and motorcycles are then used. I think it's a challenge for us because, I think it becomes a bit of a data problem. Like, do we have good data necessarily available for estimating those other modes of transport? So for instance, using live traffic for cars might work for motorcycles as well, but then if there are lots of cyclists online, then it becomes a challenge.
Yeah, it might not actually hold true, right? We see that all the time, that there's a traffic jam and then the bike lane is still free. So might lead to wrong routing decisions or Interesting. Okay, thanks. Any more questions? No? Okay, then I would say thank you, Johann. Very interesting conversation. Let's pass it on to Daniel. What do you have in store for us today?
Yeah, thank you very much. You just wanted to add that the coolest thing about working together with Wolt is that we will also have our launch a lot sooner at the Mapbox office in Helsinki. So it's good for everyone, win-win. So I would also continue on the metrics and performance side of things, but I would move over to the visual side of the maps. And I prepared a bunch of slides for it. So let's see. So we've been talking about the Matrix API, and usually what we get from a API like that is a line, which can look like this. This is a very simple GeoJSON, and what it has is a list of different coordinates that describes the turning points of a route line. It can be actually a very simple API, like developers just take a line, put it in our Maps SDK, and they get this nice looking cityscape with the line in it. But in reality, there's a bunch of different layers which our engine has to go through to get that line on the screen. And all those layers affect the performance in one way or another. So we have some things that we can control, and there are things which are beyond our SDK, but all of those can have some effect on the performance. So let's talk about them a little bit. So we usually start with a host application. It's a software which will have our SDKs. And if we talk about a navigation use case, then the end user, or the user who integrates our SDK will has to first install that. And the navigation SDK does what it sounds like it's doing. So it's going to handle all the navigation-related data management. It collects the GPS data, positions the user on the map, calculates the best route between 2 points. But that's still data. And then we take that data, we put it into the Maps SDK, which is responsible for the visual side of things. The Maps SDK itself, it depends mostly on the platforms. So we have an SDK for Android, iOS, and even for some other exotic operating systems. And inside that SDK, we have the core rendering engine where I work at, and that's where we actually put things together based on this input data and render something on the screen. So that's where we will already get something like that, which you see on the right side. But even that is not the lowest part of the system. So below us, there's this package called the Core SDK. Core SDK manages everything related to the system. So CPU threads, file system, and a lot of other things which are helping our day-to-day life as developers and connects things together. But even below that, there are things outside of our boundaries, like the operating system, which hosts the application and the SDK. And based on the operating system, we can have like very interesting specialties that affect the performance. For example, on Android, we use OpenGL to render. On iOS, we use Metal to get a visual output. And those systems work totally differently. They are totally different from performance point of view. And we also have to have some specialties to have a comparable output in the end. And of course, the hardware also defines a lot of things. We are targeting 10 years old Android devices, which are a lot slower than, let's say, the newest iPhone model. And still, they have to have a comparable output as well. And even beyond that, like if we think about like some extreme examples that can also affect the performance, we do have some external factors. Like let's imagine that we have an automotive customer and they park a car on a sunny day outside in a hot temperature. It can also affect the temperature of the CPU, which is running our maps in their dashboard. So even like the temperature outside can affect the frame rate that we are capable of rendering in some cases. So we have to consider in some cases some really extreme external factors. But the point is that we don't just think about the software whenever we are thinking about the rendering. So it's just an overview about like what factors do we have to take in consideration. And of course, when we think about speed, we also collect metrics. And based on all these layers, we collect metrics in different categories. There's actually way more metrics than these, but I picked a couple of examples and categorized them based on kind of the abstraction level that we saw on the previous image. So here I would start from bottom up, and first we can think about the metrics that we collect from the hardware. So we can think about the battery consumption and CPU and GPU usage. Those are all going to affect how the end user will feel in the end, because if the battery runs out like a lot sooner, then let's imagine that you're using a mobile application to navigate in the wilderness, it's going to be a bad user experience in the end. And the CPU and GPU usage has a direct correlation with the frame rate and the loading speed of the map. And that's where actually the software metrics comes in play. So I think like we can think about like, what is the most important from all of these. Arguably, a lot of people think about the frame time duration because that's something that connects the hardware and the user experience. So if a frame takes a very long time to render, then it will cause a lag, which will affect the user experience. And the frame can get longer because of the hardware usage. So that connects things together. But even in some cases, maybe that's not the most important thing to think about, because the user experience can also be dependent on the content that we display on the screen. So let's take an example, like network fails, doesn't load the map. Then we have like highest frame rate that we can imagine just because we don't have anything on the screen to render. It doesn't mean that the map is not rendering, but we don't have a lot of content. Therefore, it seems like that frame rate is fast, but the user experience will be still bad because we don't see anything. But still, in general, we can think about frame time as the main target for optimizations. But before I talk about like how do we even measure that, let's quickly check what does even happen in one single frame. So usually we start with a blank canvas when we start rendering. We start to render first the water areas, then the green areas and the outline of the cities. Then we put on the roads as a line layers. And if we have a map made for navigation, then we also illustrate the traffic with a different line layer. And on top of all that, we put the symbols. Usually the symbols come the last because those are a bit more special. They have to be placed in a way that everything is readable. When you pitch the map, they have to follow the orientation of the screen. So they live their own life slightly. And after that, we also use some 3D features, like we place this whole thing on a 3-dimensional globe. We have some atmosphere effects. And things are simple so far, but when you start moving the map, like all the metrics that we collect, everything becomes a lot more complex. Because if you think about it, like if you want to have a continuous motion with 60 frames per second, let's say, which will feel like you're watching a very smooth movie, then you have to do all these 60 times every second. So that's a lot of work, especially if you're moving the map and the content changes a lot. Like let's say that you want to move from Helsinki to Tallinn, then you're crossing all kind of different sections on the map. And so you cannot really reuse that areas that you already rendered. To keep that pacing, we have to re-render everything, and we kind of have a target for the milliseconds that we have for each individual frame. So you can calculate that if we need to render 60 frames in 1 second, with this simple math, you see that we have around 70 milliseconds for each frame, which is not a lot of time. And ideally, we would want to render it even less, so we could have higher frame rates for screens which can actually display higher frame rate rendering. But we also have to think about the other extreme. If worst case, we cannot guarantee that high frame rate, we still need to target at least 24 frames per second, because below that, it will feel like that the picture is lagging and it doesn't feel like a continuous motion. And for 24 FPS, we only have 41 milliseconds, or 42 if we round up. So that's still not a lot, but in that 41 or 42 milliseconds, we have to render all these things, plus make sure that we never go below that. So that's a generically good target, but it still depends a lot on those layers that I mentioned before. So how do we measure all these? Because we have those targets, we have to somehow keep them in check. We do a lot of different things. First of all, if we also start again from bottom up, we need to select the target hardware to test on. I collected a bunch of photos. So on the left one, you see my desk, and it has a bunch of different devices from different providers and generations. We also have some Android devices from 10 years ago, and we have also the latest iPhone models, and we have to make sure that our map loads in a similar speed on both of those, and they have comparable frame rates. Plus, these devices sometimes have some specialties. Sometimes their GPU has some special problems that need like fixes meant for those device types. So we run those tests sometimes manually when we have to cover these like special cases. But whenever we change a single line of code, we also run tests automatically in our development pipeline. Some of those tests are running in the cloud, but the cloud actually is just a collection of different devices that someone else is hosting for us. So it's not really like a virtual or like a cloud implementation. It's just, it means that those devices are not in our office. But at the same time, we do have actually some devices which are inside in our office. You can see those in the middle image on the bottom. Those devices have some specialties that we have to check, and they are not supplied by other manufacturers. So we have full control over those, and it's great that we can test with these in-house device lab. But at the same time, it also takes a bit more maintenance to keep everything up to date on those phones. The main thing is that we run these tests automatically whenever we change a single line of code, and it makes sure that the tests that we run on those devices are producing frames in a duration which is below our target. And on the right, I didn't include a photo, but we also have some proprietary testing hardware. These usually come from manufacturers who have their own target specifications that we have to test on. They have a lot more different resource management policies. So we are even limited by the amount of CPU or GPU resources that we can use in those. They are very interesting to work with, but at the same time, they also help us to optimize our maps even further because we have to work in a lot stricter conditions. And now I showed you the hardware, but let's talk also about the software that we run for those test cases. There are also like a different variety of test cases that we have to consider in each of those runs. The simplest one is just to render a single frame. We usually do that by installing a clean application, which maybe has some preloaded data on the disk, but it has to render everything by just starting up the application. And what we measure with that is the user experience of the first install of an application. And that's very important because in some cases, like waiting 1 or 2 seconds can make a whole different user experience on a new application. Then the next thing, it's a bit more complicated. We also measure how quickly can we do gestures on the map, zooming in and out. When we do that, we cross different levels of detail on the map. We can start from the level of countries, zooming in, seeing cities, and then all the way down to the street level, where we have different type of labels and specialties on the road. Even like sometimes pitching the map to show like details on the distance can have a whole different content rendered on the screen. So those are going to put some pressure on the map during those animation, and we still want to keep that median frame time and reduce all the peaks which might happen during those animations. Then we also test for special effects or 3D features, for instance, this terrain or the globe or even the atmosphere in the back. We sometimes mix these, and then we have gestures running on the globe or on the terrain, and we will see kind of like permutation of all these tests running in parallel. Plus, we will see also which hardware and which test had the best or the worst results in the end. And then we have a special test case, which is a long-running navigation session. And when I say long, it's actually really long. Like usually the shortest test that we do is still 1 hour. And we can run tests up to 10 hours in some cases if we want to see that the resource usage stays flat. And these things, even though they sound extreme, it can be a totally realistic use case. Like let's say that I use a navigation application to go from Helsinki to Rovaniemi. It can easily take 10 hours. And the user expects that the application won't crash, it won't run out of memory. And so we have to verify this by actually running those maps for 10 hours in our device lab. And with all these tests, we cover the hardware and software part, but there's a lot of things which depends on the actual context. So if you want to see the fastest map ever, just go to the middle of the ocean, and that's it. So there you have to render a single symbol. It can easily be rendered in 1 millisecond. You can have up to 120 FPS or even more, depending on your device. And it's constant, nothing to worry about. Then you go to a condensed city, and things start to get a lot more difficult. And you can still have the same device, same hardware, same operating system, same style, but it will be a lot slower. And this is actually where I think the example with Tokyo comes in handy, because like that's one of the hardest parts to render on our maps with all the special details that city has. So in our tests, actually, we do target Tokyo as one of the test cases where we do zoom in and zoom out quickly, and we want to see that we have still like at least 60 FPS in some cases. Of course, with some older hardware, it's harder to guarantee, but 24 FPS should be the minimum, even in Tokyo. And one other interesting example about the context is these 3 examples. On the left one, you clearly see that we have terrain enabled. And the question is that, do we even have terrain in the other 2 examples? I will answer it. The middle one also has terrain, but the elevation is set to flat. So basically it's a 0 height elevation. And what this does is that we do use the resources that we need to render the terrain. But in some cases, this might make sense, even though it sounds like a bit counterintuitive, and you will start to think about that, okay, if we have terrain enabled, then it should use more resources, so the performance could be worse. But terrain can be also used as a performance optimization, and some customers figured this out. Because what terrain does is that we render things first into an intermediate texture, and then we put it on this wireframe of the terrain, and those textures work as a cache. And if there's not much dynamic content on the map, like let's say that we are not animating the colors of the lines and we are not moving the camera, then those textures are going to save all the content that we rendered, and it will speed up the rendering a little bit, even if we have a feature enabled. So this is an interesting thing to think about, because we also have to realize sometimes that the way the users use the map is counterintuitive to us, but they get better user experience with some features enabled, or they have faster rendering speed. And here's one more example for contextual difficulties. This chart shows a number of bed frames over time. Bed frame means that we are over the target that we had, and we are losing frames because of that. So those are like very long frames. And it shows collected data for more than a year. And I was thinking here that, okay, can we even fairly compare this data with the data that we have today? Because, because the problem is that during that 1 year, so many things changed. So we had new features added to the base map style that we use. We have 3D features now, like the globe. It didn't exist a year ago. We have now test cases which are testing for fast zoom in, zoom out. But at the same time, we also did optimizations on the engine. We got optimized operating systems and faster phone models. So if we just aggregate this data and we automatically collect the latest one, it won't be always comparable with the old data points that we have. So I think the rule of thumb here is that we only compare the latest couple of releases where we still had the same setup. We have to always collect also the context. So we don't only just collect the raw data, we need to know the phone models, map version that we used and all that. And if you want to compare the system in a state from a year ago, I think the best thing to do is just to run the test again, using the same configuration, same hardware, same operating system, but using the old software version, because that's the only way how we can guarantee that there will be a comparable output. And the last example I have here is a bit more about the feeling of the loading of the map. So we have two animations here, and both of them shows a map loading. And I think the right one feels a bit faster because we see content sooner. But in reality, actually, both map loads at the same time. So the completion of the loading happens at the same time. And if we measure only that, we had a test case which measures this map readiness, then the resulting value would be the same. But in reality, it feels faster because we have content sooner rendered on the right image or the right animation. So this also shows us that sometimes collecting some metrics is not enough. We also have to think about how does it feel to use the map. So with that, I would like to summarize these presentations, and I think what we can conclude is that we can collect all those metrics, and those are great to guarantee some performance targets. But in the end, what matters the most is the user experience, because that's what's going to decide how do we feel about using our maps. And that's true for both for navigation and both for the rendering of the maps. So thank you very much.
Thank you, Daniel. A very interesting presentation. Do we have any questions from the audience?
We do have one question from online, but this is perhaps for Johann. So we have Ravi. Hi, I would like to know if incorrect address or missing address is a challenge. And this is perhaps talking about in case the user gives out a wrong address, what does the process look like?
In case the user gives the wrong address, I think you can reach out to customer support. That's pretty common. Like, they will do an amazing job, hopefully respond within a few seconds and update the address in case something got screwed up there. I'm not sure, to be honest, like with logistics, how often we have to deal with this problem. We, in a way, take the deliveries we receive from the main system as is, and we kind of don't think too hard about whether the address was correct or not. We just deal with coordinates in our system.
Thank you. I have a question to Daniel. So we had this product launched called Mapbox Globe. For those of you who don't know, it's actually a really fun feature where you can eternally zoom out of the map until you are in space, more or less, and you can spin the globe around like all kinds of directions. And I'm wondering what effect that had on rendering, like if you had to change your pipeline, or whether there was even this effect that you saw with terrain where you had a feature enabled and there's actually some positive effect on the performance.
Yeah, so that's an interesting question. The delivery of Globe as a feature, it certainly opened kind of a can of worms related to performance. Luckily, it was already like out of box. It was pretty good, so we didn't have to like lower our expectations. But it does actually introduce some like increased resource usage, because basically the way the globe works is very similar to the terrain. So it also first have to render to a texture, and then that is placed on the surface of the globe. So in those cases, similar optimizations that we can expect from the terrain comes in, but at the same time, because it's a more like complex shape and it has more vertices, and it does have some extra work that we have to do during rendering. But it also has kind of like a geometrical implication, because when the globe is enabled and we zoom out, we start to see more content towards the poles. So in the beginning, we actually rendered a lot more content because the map was designed for this flat projection. And with those, we split the map into these tiles that are evenly distributed on the surface of the map. But when we turned it into this sphere, suddenly those tiles start to get more condensed towards the poles. So we had to adjust it to load less content. Otherwise, it was increasing the network usage, and also it was rendering more content, especially when things were closer to the camera. So when we are zooming in, we by default see more content. But if we also see the poles on the globe, suddenly it was rendering so much stuff that it was a lot harder to handle. But these are like just one of the many examples where we had to do some kind of custom performance optimization, and the latest version of the SDK has a lot of these things in it. So a lot of these improvements that we've done. Some of them are related to the globe, some of them are related to the terrain. We also further optimize like the terrain with the flat elevation, because some customers just need that. So we have to think about a lot of edge cases, but all those edge cases does add up in the end in the effect of the performance.
Thank you. Any more questions from the audience?
I have one, maybe not really related to metrics as such, but I'm a bit curious. When switching to this new globe model, like, did you have to change, like, massive changes to the rendering pipeline itself, or how hard was that?
Yeah, so it did have some changes. I'm not even sure actually where to start, but I think like one interesting thing about that is that alongside with the globe, we also worked on the GeoJS side, so the web version of our maps, the rendering of different projections. So the globe is one projection type, even though it's kind of like a reprojection, so it's not like from the Mercator data that we have. So it's not classically the same, but we still consider it as the same concept. And so we had to think about the abstraction of how we manage different projections, including the globe and other types that we have now on GeoJS. So one part of this setup was to think about a new abstraction that can cover all those, plus a new, of course, a side of the rendering pipeline where it will be rendered on the globe or on those different projection types. And so as I mentioned, like the strategy is similar with to the terrain. So basically, we render those data that we are going to place on the globe into the textures of a terrain, basically, and then we put those textures on the surface of the sphere. So we started basically with the implementation of the terrain, and then the biggest changes that were added actually is the abstraction for the projection, plus the implementation of that globe sphere rendering. And if you're interested more about the actual technical details, you can just look into the open source code of GeoJS, because the whole globe implementation is also available there. So you can just see all the commits and even land fixes if you want to.
That sounds amazing. Yeah, thanks.
Cool. Do we have time for one more question, or are we at time? Okay. Daniel, we have this picture that you showed about the device room. I've been in that ominous device room. It only showed part of what this looks like. So I'm seeing a lot of mobile devices, but the other half that is not shown are automotive grade hardware devices. And since we sort of started engaging a lot more and have a lot more automotive customers in recent years at Mapbox, how did that change the work for your team? What was the most surprising things that you encountered working with automotive customers?
Wow, that's a really cool topic. I think I could have like another 20-minute long presentation. But yeah, so at the same time, it's also a bit difficult to talk about it because I don't know like what is covered under our NDAs. So that's why I didn't include the picture. But
Right call.
yeah, but at the same time, I think I can say some things in general. So the biggest two things is that the automotive use cases, like the map is constantly moving. So you're navigating, you're like doing some gestures, zoom in or zoom out. That's like critical. We had to actually implement some new test cases to cover those. And the other thing is these like super long running test cases, like when we have to navigate for 10 hours easily. And especially when we have these like very long routes, if we just load those very long lines, let's say from Helsinki to Portugal, or to Lisbon, and in those cases, like just rendering that single line can be like a tricky thing. So one cool thing that we had to develop to test these cases is kind of a replay system. So the navigation SDK was already collecting GPS data, and they can visualize it, and they can see like when was like the data incorrect and so on. But we didn't really have a playback system in our rendering engine. And we teamed up with some people in the team, and we created this so-called map recorder, which can also record the position changes on the map, but we can also, using some other tools, convert these data that we collected from the GPS data, turn it into a sequence, and then play it back. And that's amazing because if we see that, yeah, let's imagine that we are navigating from Lisbon to Helsinki, or vice versa, and then we had some slight performance like loss when we were crossing, let's say, Germany. And you wouldn't want to play back a whole 10-hour long session, but we can collect this data, turn it into this sequence, and then we can point to this exact moment in time when the GPS coordinates were there, load that file into our engine, play it back, and we will see that, aha, it's slowing down because there is a very condensed road there, or there are some issues on the style. So with these recording and playbacks, we can have a lot more flexibility to test these cases, but it's still under development. So like this is definitely like one of the side effects of working with the navigation customers, plus like all the dynamicity that comes with it.
Thank you. If there are no more questions from the audience, I am going to thank you too. Thank you, Johann, for taking the time. Thank you, Daniel. Thank you, audience, for joining us tonight. And for those of you who are online, please subscribe to the Mapbox channel. And if there are more questions coming to mind to the two of them or to Mapbox, please drop them in the comment section, and we'll make sure to address them over the next few hours and days. Thank you very much.
Thank you.
Thanks.